الرحمن الرحيم.
Solve the given differential equation by undetermined coefficients. So we have this differential equation, y double prime plus 4y equals 3 times the sine of 2x. And what we'll do is we'll want to find a solution y that's equal to a complementary solution, y sub c, plus a particular solution, y sub p, where y sub c is the solution to a homogeneous version of this differential equation. In this case, we have y double prime plus 4y equal to some function g of x, but what we'll want to do for the complementary solution, so to find y sub c, is we'll want to solve y double prime plus 4y equal to 0. And for an equation such as this, a homogeneous one, we can let y be equal to e to the mx. So in this case, y prime will be m times e to the mx, and y double prime will be m squared times e to the mx. Now when we plug those into the equation, we get m squared times e to the mx plus 4 times e to the mx equal to 0. And we can factor out the e to the mx, and the other factor will be m squared plus 4. And that product will be 0. Well, e to the mx can never be 0, therefore m squared plus 4 will be 0, telling us that m squared will be negative 4, or m will be plus or minus the square root of negative 4, which will be plus or minus 2i. So m will be negative 2i, or m will be equal to positive 2i. Well, let's take a look at our solution. So the first one would be e to the 2ix if we substitute 2i for m. Well, that will simply be the cosine of 2x plus I times the sine of 2x. And then e to the minus 2ix, that will be the cosine of negative 2x plus I times the sine of negative 2x. And so then that's going to be, because these cosine is even and the sine is odd, that will be equal to the cosine of 2x minus I times the sine of 2x. And what we'll do is, since these will each be solutions, then a linear combination of the two will be solutions. So we'll have some linear combination of the cosine of 2x and I times the sine of 2x. So we'll have a complementary solution y sub c of c sub 1 times the cosine of 2x plus c sub 2 times the sine of 2x. So now we'll need to find our particular solution, y sub p. Well, we should note that the right-hand side, that g of x, is equal to 3 times the sine of 2x. And so what we'll try to do is find a possible function that we can use to check to help us with this. So we could come up with something, but we do have a table that can help us. So here we have the following table. So from the looks of the form of g of x, it seems that we should use something similar to number 5, where we'll want to use something of the form a times the cosine of 2x plus b times the sine of 2x. But we should note that this sine of 2x and the cosine of 2x, they match what we have here in the complementary solution. So if that's the case, then we're going to add an x. So we're going to not use this possible function, and we're going to use ax times the cosine of 2x plus bx times the sine of 2x. So that's going to be our particular solution that we can check, but we need to know what are these constants a and b. So we're going to have to substitute into the differential equation. We're going to have to find, well, we know what y sub p is, but then we'll have to find y sub p prime and y sub p double prime. So first we'll find y sub p prime. And so for that, we can easily just use our product rule and differentiate. So we can find y prime sub p, and then we can also find y double prime sub p, and y double prime sub p plus 4y sub p. If we evaluate that, we'll wind up with the following. So we can easily verify that y double prime sub p will be minus 4ax times the cosine of 2x minus 4a times the sine of 2x plus 4b times the cosine of 2x. And then we're going to have a minus 4bx times the sine of 2x. And then when we add 4 times the particular solution, we'll add 4 times ax times the cosine of 2x plus 4 times bx times the sine of 2x. And the 4ax's times the cosine of 2x's will cancel. The 4bx times the sine of 2x will cancel with this negative, and we'll just be left with these two here. So y double prime sub p plus 4y sub p will be equal to negative 4a times the sine of 2x plus 4b times the cosine of 2x. And that should be equal to, well, this g of x, 3 times the sine of 2x. So we can see that there is no cosine on the right-hand side, so b will have to be 0. But negative 4a is going to be 3, telling us that a will be negative 3/4, and now we can get our particular solution. So we have our complementary solution, we have our particular solution, and so now what we need to do is we noted that a should be equal to negative 3/4 and b will be equal to 0. So our particular solution, y sub p, will simply be negative 3/4 x times the cosine of 2x. So now our complete solution, y, which is the complementary plus the particular solution, will be c sub 1 times the cosine of 2x plus c sub 2 times the sine of 2x, and then we'll subtract 3/4 x times the cosine of 2x. So using undetermined coefficients, we're able to solve this differential equation by writing it as a complementary solution function plus a particular solution. And using this particular solution, we're able to find the constants necessary to make this function agree with what we have in our differential equation.